The next part I'm going to tackle is this large pulley. It's very similar to the small pulley, but we'll concentrate on the large one. They're both made using the same technique. Here's a close-up of the pulley. Like the flywheel, it has a recess dished into it. It has a spoke pattern that has to be drilled out. There's no recess on the other side. Of course, there's a groove cut in here for the pulley, which I'm going to use an O-ring for that. Now, since this part is made out of aluminum, which is cheap by comparison, and I have a long rod, several feet long actually, of this size, so just cutting a piece off it and machining from here and machining the hub is all one piece is probably the way I'll go. This is for a set screw, and I may not have mentioned it, but pretty much every part that sits on an axle is going to need a set screw drilled and tapped in there. So we'll head downstairs and tackle this next. I've been working on the pulley. It sits on top of the helicopter and drives the main rotor. It's very similar in machining features to the flywheel we just made. But, well, obviously it's made out of aluminum. It's one of the few parts on a helicopter that is aluminum. And, well, aluminum is a lot less expensive than brass. I happen to have had a long rod of aluminum that was, the proper diameter. So instead of having to, force a hub into it, I'm just working with a solid piece, and we'll just machine the hub from this other end here. The trick is, this is smaller than the flywheel, and when I made the flywheel, I used the reversible jaws to hold it when I flipped it around. The problem is, when the jaws are reversed, they can only close to a certain point, and then they hit, and well, they won't hold this. This piece is too small to be held in the reversible jaws, so I can't do what I wanted to do, which was flip the part and work on this side. But I'm always on a quest for finding new ways to hold material because of all the problems we've run into. And I saw some YouTube videos of people using mandrels. So I just purchased this. In fact, I purchased them in a few different sizes. But what this is it's a machined piece of steel. This particular one is 1/4 inch. And it's machined in such a way that there is a very, very fine taper, in tenths of thousandths, down to the actual quarter. And what you do, in this particular piece, I've already reamed this out to a 1/4 inch because we have to put some bearings in here. This will slide in to a point, and then if you just, press it a little further, I'll go over and use my arbor press to do that. You don't have to press it very hard. You'll get a nice grip on here, and then you can just, hold it any which way you want and work on it. Then when you're done, you go back to the arbor press and you push it back out again. So let me go get set up for this and we'll try it. Like I said, I've never done this before, but this seems like a very clever way to hold pieces when the chucks won't. All right, I've pressed the arbor into the part, mounted it in a 3-jaw chuck. And now I'm just going to find my X and Z coordinates. Same as I always do. Just jog this in until it touches. And that is Z0. Actually, I think I've got this at too steep of a... When I'm turning, I like to angle the bit, you know, instead of having it totally square, because if I'm machining to a shoulder, as I will be here, this lets the cutting edge cut the shoulder. If it's flat, it just isn't quite right. So let's try that again. Z0. X by touching it this way. Okay. And this stock is 1.625 inches, so I'll set my DRO for X right there. And now we're going to have to remove a ton of material here, because we have to machine this whole block down to a hub. But machine ought to be able to do that. The arbor seems to be doing what it was meant to do. Just hold my piece. If I had known that I was going to use the arbor for this, I wouldn't have left anywhere near this much material. You know, as I said, I thought I was going to be reversing this in the jaws, in which case I would have needed some, you know, some meat there to hold on to. But it's no big deal. Machine does all the work. Playing with the speed here to try. Alright, I'm gonna... Something is definitely not right. I'm wondering if I didn't push that arbor in enough. might be rotating on that arbor just a bit. So let me take this out, press that arbor in a little bit more. Like I said, I've never done this before, but I've certainly seen others do it. I know it works. Well, there were a couple of things going on. I pushed the arbor in, I don't know, at least another ½ inch. I just didn't realize how tight it really needed to be. The other thing is I backed off on the amount I was removing on a pass. I was removing 5/1000ths, and now I dropped it down to 4. The other thing is I've been working with brass for the last couple of weeks, where you don't have to use any lubrication when you're turning. And obviously with aluminum you do. So by pressing it further onto the arbor, reducing the cutting depth, and using cutting fluid, it all seems to be working just fine now. Well, anyway, I'm not going to make you watch this. It's going to run for a while. Like I said, there's a lot of material that has to be removed, but I'll get back to you when we've got something new and exciting to do. The adjustments I made to how tightly I was holding the mandrel and using cutting fluid and such worked. You know, that was what the problem was. So the hub is turned down to where it needs to be. What I'm going to do now is dish out a portion of this, just like we did with the flywheel. That's actually fine. I was going to go a little bit deeper than that, but that's fine. Again, this is just a visual element. So the only thing that's left to be done is, well, the hub is much too long, so that's going to have to be cut off. And then later we're going to drill a hole into the hub to put a tiny set screw in here to hold this on its axle. And then we'll go over to the milling machine later and we'll drill a hole pattern in this recess. You know, it's just a spoke pattern. It lightens up part of it. But that's about it for this. I'm going to sand this just like we did with the flywheel, The only difference is the micromesh paper I'm going to use is specifically made for aluminum, and micromesh gives that a designation of AO, which I assume is aluminum oxide. And the other difference is, instead of using mineral spirits as my cutting fluid, on aluminum I use water. So I'm not going to take you through that, you've seen the process, but just those minor changes. Oh, and of course, I almost forgot the most important part. Since this is a pulley, we're going to need to cut a recess in here for the O-ring to slip into that acts as the pulley belt. So I guess I'll do that now. Let me switch over to a parting tool and we'll do that. All right, I've switched over to the parting tool. I moved it into position. As always, I disconnect the stepper on the X cross slide and just advance this with manual feed. Nice slow RPM. Come in until I touch. Right there. Set the hand wheel to 0. And we're going to go in, let's see. Try this at 30 thousandths depth. The blade is 40 thousandths wide and we need an 80 thousandths groove, so I'm just going to scoot over and finish this. I have two different O-rings. They're both 40 millimeter in diameter, and O-rings are always measured on the inside diameter. But this smaller one is 1.5 millimeters wide, and this one is 2 millimeters wide. And I honestly haven't decided which one I'm going to use as my belt. The 2 millimeter fits nicely in there. And 1.5 millimeters, that's probably a better fit because that's sitting, in the groove with a little bit of extra room. So I probably won't make that decision until this entire thing is assembled, but I suspect that either one that I choose will work just fine. I mean, it is a very, very low RPM setup, so it probably won't matter. A few videos back, I did some filing on the lathe, and that generated quite a number of constructive criticism comments, telling me that my technique was, well, it needed improvement. So the people that contacted me were very helpful. I mean, they pointed me to some good YouTube videos to show me the proper technique, and I really appreciate that. I'm going to try to do this the proper way now. And please, I encourage you, if I'm doing something wrong, to, make comments like that. Show me the right way to do it. I bought my lathe and my milling machine 5 years ago. Before that, I had never worked with metal before, other than to cut a piece of it with a hacksaw. So I am, very new to this process, and although these videos are intended to teach, I'm also here to learn. So I encourage you, if I'm doing something wrong, point it out to me. What I was told was that, first off, you're supposed to put a handle on the file. That is, it's a safety measure. Honestly, I'm not convinced that that's any safer, but I will follow that direction. The other thing is the file cuts on the forward stroke. So you cut and you come back. The other thing is you're supposed to stay, the file is supposed to stay parallel to the, both to the bed and to the chuck. So I just want to put a, slight bevel on here, so let's just try it that way. I was also told, use the full length of the file, so well, that's certainly giving me a nice look, and to be honest, it does feel more, it feels better. I feel like I have more control than the ridiculous method I was using before. Alright, so that's my coarse file, and I'm going to switch over to the finer one. My coarse file actually is probably just a medium file. I don't use a coarse file on this, but my coarse burr file. Alright, that's nice. Now I want to do the other side of this, and I don't dare put the, try to get the file in there, so I'm going to flip the part around and file the other side just the way I did this one. And then I guess, I'll do the cutoff here, and then the rest of the operations are on the mill. Next, I'd like to work on the main rotor head. This is the main rotor head. The plans that I'm working from only had 2 blades
on the main rotor. So it was a much simpler part. And although there certainly are helicopters with 2 blades, I just felt that 3 would look more aesthetic, if nothing else. So I came up with this design, to hold 3. It's machined out of a block of aluminum, and I'll be able to use just a single block. Initially it's just, a circle with a slot cut into it. The tricky part, though, and there's no reason for this other than, again, aesthetics, because this would certainly work, as a disc with 3 holes in it. But, I drew it this way with these cutouts here, and that should just add to the machining fun. There's a recess here for a ball bearing that has to be machined in, and then this collar down here slips into the shaft on the pulley that sits just below this, so the 2 of them lock together again with a set screw. So this should be an interesting part to make, because part of it's done on the lathe, and then we've got to move over to the mill and cut these parts out. So let's head down to the workshop and tackle this.
I just thought I'd give you a peek at where we are so far. Quite a few of the pieces have been made, and you've basically sit back and watched me do all of that. I've done a lot of sanding. This is the pulley we just made. This came out very nice. I know there was chatter in here that you could see on camera, but I couldn't see. But anyway, I was able to sand that out. I also went ahead and made the mating pulley, which is, same techniques, it's just tiny. And what I've been working on this morning is the main rotor head for the helicopter. This is what's going to hold the propellers in these slots. And if you recall from the drawing, there are 3 holes that get drilled through here, and then screws get put through and they hold them in. Now, I could very easily just leave it like this. It would work just fine, but I drew it to have this shape to it, and I think I'm going to go ahead and try to do this. It's a little tricky because I've already slotted this. So I would do this on the milling machine, obviously, but cutting out pieces that can't be clamped, if the scrap part can't be clamped, is very, very dangerous. Because as you get to the final part of the cutoff piece tends to flip up or down into the blade, into the end mill, which can, really make a mess. So what I'm thinking of doing, I printed out a set of these plans at actual scale, and I've cut out the rotor head, and it's on a piece of 2-sided tape. So what I'm going to do is cut that out, tape it on here as a reference. So anyway, if I tape this onto here, I can use it as a pattern, go over to the bandsaw, with the part pressed in to here, just to use it as something to hold on to, and cut away, the majority of that material. Then I'll feel much better coming in with an end mill and just cleaning it up. Then we'll just drill the 3 holes, and that's pretty much what this, what needs to be done on here. So let me go ahead and do that, and I'll meet you at the milling machine. All right, I took the bandsaw and I cut out as close as I could to the rough edges of the final part. I wanted to leave as little material as I could without, going too far and messing things up. So the part is now mounted in the four-jar chuck. This is a self-centering chuck. It's on the rotary table. The rotary table is set up so that the XY0 is the dead center. And I've written a little G-code program to fix the, cut this to the actual profile as it is in the plans. We've got an 1/8 inch carbide end mill in here for flute. It's going to make 2 passes. The first one at 2 depths. The first one will clean the high part above the slot, and the second one will clean the entire thing. And then we'll go back and do a finishing pass. There's not much, the jaws are certainly holding this, and unlike the flywheel disaster that we had a while back, this hub that it's holding onto is an integral piece. It's all the same piece of aluminum, so we don't have, a press fit to deal with. But still, there are enormous cutting forces, even removing something as small as this. And, it's all being held here by the hub. I mean, the parts we're actually cutting have nothing holding them, except their, connection to the hub. So I have no idea if this is going to work. But what the heck, let's give it a try. The G-code thinks it's cutting out a pie piece like this, so it's cutting air here. Dropping down to the second depth. So far, so good. Well, see, all that worry was for naught, at least so far. All right, I left about 6/1000ths behind so I can do a finished pass. So let me load that block of G-code. The finished pass will do this all in one depth. So, let's see if we can go 2 for 2 here. Obviously it's plunging at a very, very slow feed rate. All right, now that the first cutout has been milled, since there are 3 of them, we have to advance the rotary table 120 degrees. So okay, now it's in position to mill the second one. And now for the last one, I'll just advance the rotary table another 120 degrees, which is 240. Not bad. All right. All that's left to be done now is to drill the 3 holes. Now they have to pass through, both pieces here. And I'm thinking, I could be wrong, I often am, but I think a drill bit exerts a lot more downward force than an end mill, a small end mill when you're doing this. And I'm just wondering if I'd be better off just plunging the end mill through these holes, because it's the same diameter as the drill bit I would use. I could be wrong, but my gut tells me that that is safer. Because I'm afraid that the downward pressure on here from a drill bit might deflect this a bit. Let's just see what we can do here. Do the first one. And now we're retracting. Alright. That certainly worked. I don't know if the drill bit would have been better or not, but as long as it's working. Let's just do the other 2 holes. Alright, let's see what we got. Not bad. Not bad at all. A little bit of sanding, and you know, I've got to trim this hub down, but I'm pleased. I'm pleased with the way that turned out. I'm glad we took the extra time to cut these out rather than leaving it just as a big disc. So that part is essentially done. All right, I've completed the pulley. This is the larger one, obviously. There's a small one, very small. This is the drive pulley. You know, this O-ring will be used as the pulley belt. Like that. This is the completed pulley. I've drilled 3 holes in here to give it some sort of a spoke pattern, and the reason I chose 3 is because I decided to use 3 propellers on the main rotor, and I just thought that if we offset so that each hole is between one of the propeller blades, it would just have a nice symmetric look to it. There are ball bearings pressed onto either end here in recesses that I've reamed. You know, so everything moves, you know, nice and freely, which is the whole idea. As I've said before, you know, Stirling engines have very, very little power that they generate, so you have to minimize friction every place you possibly can, so that that small amount of power can, you know, drive all this stuff. But itsy bitsy ball bearings do the job. So that's where we are. I'm going to take this little set screw here. This is just a 632 thread. It's tiny, sitting on the end of the Allen wrench. And I'll drill and tap a hole here into this hub. So that will attach the large pulley to the main rotor head. So they both turn in unison. Right now it's just sitting in there. And likewise, The flywheel will have a set screw, and there are numerous parts in here. Anything that has to be affixed to one of the axles will have a set screw put into it. To finish up the pulley, we have to drill a hole in the hub for a set screw. So I thought I would take you through that. I'm using a neat little tool that Stirling makes. They call it the sensitive drilling attachment. And what it is, it's a very, very small drill chuck. It's intended for, your smallest, like your numbered bits. And it's spring-loaded. The sensitive drilling attachment essentially turns your mill into a tiny drill press. And it lets you use hand pressure and feel to drill very tiny holes, the kind that, using a CNC would probably snap a bit. And I find it, I don't use it a lot. There are times when it's just the perfect tool for the job, and, well, this is one of them. So I'm just going to hold the hub in the vise. I've got it, sitting in the little groove in there to hold round pieces. It doesn't have to be very tight because, well, it doesn't have to have a whole lot of grip because we're applying very little pressure here. Now what I've done is I've indicated with my edge finder off the back jaw and the side jaw, and then I just moved my XY coordinates over so that I'm sitting in the center of the hub in this direction and in this direction. So now, a little cutting fluid, a bit of RPM, and again, just by feel, I'm drilling. And I'm just bringing the bit down a bit, coming up, clear some chips here. There. I can feel it right through. I know exactly where I am. I'll switch over to my tap wrench. I'm just using the mill to keep the tap wrench on true vertical. And I just tap out the hole. Okay, it's through. Now I can take one of those ridiculously small set screws. Just test it. And that's done.